Thank you for joining us for today's webinar, sponsored by the California Fire Science Consortium and part of the UC Davis Forest and Fire Ecology Random Lectures, or FARL series. My name is Allie Paulson, and I'll be your host for today's webinar. I'm the coordinator of the Sierra Nevada region of the California Fire Science Consortium, and we're a fire science outreach organization. Our mission includes increasing communication between fire researchers, managers, policymakers, tribes, landowners, homeowners, and other stakeholders. The California Fire Science Consortium is part of a nationwide fire science exchange network funded through the Joint Fire Science Program. So first off, a few housekeeping items. We are recording the webinar and it will be posted within the next couple of weeks to our YouTube channel along with closed captioning. If you're having any technical issues, please feel free to send me, Allie Paulson, a private chat using the Zoom chat box, and I can help you once we get started. Also, we'll be using the chat function in Zoom to collect any questions for our speaker. Feel free to type a question here at any time during the talk, and we'll address the questions in the order that they're received. Now I'd like to introduce our speaker, Dr. Peter Grierson. We're very excited to have him today. He was originally scheduled to present last year in March, just at the start of the pandemic. So we had to cancel that talk, and we're excited to have it rescheduled for today. Peter is an adjunct professor in the Department of Plant Sciences at the University of California, Davis, and he's co-chair of the International Union of Forest Research Organizations Task Force, Resilient Planted Forests, Serving Society, and the Bioeconomy. He's a member of the California Board of Forestry and Fire Protection Effectiveness Monitoring Committee. And he's worked on forest sustainability, the benefits of urban green space on air quality, and the role of forests in climate mitigation. He was the UK Forestry Commission's Chief Scientific Advisor from 2010 to 2017. So without further ado, I will pass the presentation over to Dr. Peter Grierson.
Thank you very much, Ali, and thank you everybody for logging in to hear this presentation. I wanted to say, Ali's right, I am now in plant sciences. I was in ESP, Environmental Science and Policy Department, for the first 3 years I was here in UC Davis, and the move was only for basically administrative reasons, the move of departments. And I wanted to thank ESP for being such a hospitable group. So a number of you on the call and Hugh Safford's group were really hospitable to me when I arrived. It was great, so thank you. I really hope you enjoy the presentation today. I've got a few, not quite enough probably, pictures of some nice forests, and I hope a few interesting ideas to present to you. And I should say that the work I'm going to present was sponsored by this organization, the European Forestry Institute, which is very, very closely linked with the European Commission, the EU Parliament. Basically, it tries to be their science provider on forestry issues. So just to acknowledge the funding. That organization, the European Forestry Institute, publish annually, roughly annually, these reports. They're called From Science to Policy, and they normally get a group of scientists together to produce a document which they feel is timely to try and influence the European Parliament in respect of the opportunities that forestry presents to the Parliament. So this is the document that was produced at the end of 2019. Actually, really was the end. It was something like the 22nd or 23rd of December. And it was presented in Brussels on the 17th of December, I see here, reminds me at the bottom of the slide, at the International Press Centre. And we did get a number of members of the European Parliament at that presentation. So it was that, really the context is that to try and get a report that was moving forward forestry policy and having some influence on members of the European Parliament. And the only other thing is to say that you can get hold of all of these from Science to Policy publications on the website that I've put up there. So I'm going to present some of the data in that report. It's quite a big report, massive number of references, as you'd expect. So I can't really do justice to it, but I'm going to try and present 4 snapshots of content. And one of the bits of snapshot I'm going to do in a bit more detail, because that was the one actually where we managed to do a bit more original science. And it's always nice to try and do something more than just review literature, to do something that is genuinely new and therefore perhaps a bit more interesting. So I'm going to spend a bit more time on that. The policy context, I apologize, I'm sure you know all this from this group, but I guess thinking globally, so you don't always think, if you're thinking about US policy, about development objectives, but you know, the role of forests globally in actually reducing poverty and to some extent contributing to reducing hunger is not trivial. And then there are conventional wood uses, which globally includes a lot of fuel wood actually. And then the new policy measures around biomass energy and the bioeconomy. So these are all things that are in things like the UN Sustainable Development Goals and actually some national policies. Climate mitigation, I guess this is maybe the only area where this presentation has got more relevant over the last year rather than less relevant. That's because the Framework Convention on Climate Change, and particularly the commitment to independently determined national contributions under the Paris Agreement, the contribution of forests to those is actually substantial in sub-countries. Somewhere like Russia, for example, it's massive. And obviously, you know, the US will be thinking about that more seriously again now. And it certainly is important in the European context. And then if you like, the conventional or established, probably is a better word, environmental targets under the Convention on Biological Diversity and the International Convention on Plant Protection. So those are important. So forestry is always quite a complicated policy arena, as I'm sure you know, slightly more focused. The work that we were asked to do for that particular annual From Science to Policy report was really focusing on plantations. And that's an interesting issue, what a plantation is, how intensive your management has to be in order to qualify as a plantation, and the various issues around intensive forest management. So that was a little bit more our target. And this is because plantations are very productive compared to natural forests. So, you know, 7% of the world's forests is plantations, depending how you define it. About 7% of the world's forest area is plantations. And that is responsible for 33% of the world's roundwood supply. So you can see that's a very effective contribution from quite a small land area. So the issue for plantations is that in spite of that high productivity, they are not always very popular with local populations. So there is an increasing demand for timber globally, but still a decreasing forest area globally, but an increasing plantation area. So how do we reconcile the fact that our policies are increasing plantations, and yet these are less popular often with local communities? And this is something that if you're involved in forestry policy, you know very well, but it's worth remembering that public concern over forestry, public protest over forestry policy sometimes can be quite near the surface. It's interesting that that does often focus on intensity of forest management. So things like monocultures, this is a paper from Germany, Federal Republic of Germany. Monocultures particularly been criticized there. This is a paper about China and Brazil, where it is commercial tree plantations that are the issue. And this is, Bulgaria, where it's about public forests being cut down. So the same sort of preference, the public preference for natural and public accessed forests and dislike for commercial forestry plantations. And this is the group then that, this is, I think, my acknowledgements. This is the group that was put together to do this particular report for Brussels. The question really was, is forestry, plantation forest in particular, delivering the environmental and socioeconomic policies that it could be, particularly climate mitigation and the bioeconomy, where the emphasis is. So is it meeting its full potential? And what can we do to increase that potential through management particularly? So, I mean, it's a good group. I've put the names up there. They were a great group, actually. We met early in 2019, very cold day on the edge of the River Rhine there. And then later, you can almost guess by the flowers and the sunshine for Europe. This was a subsequent meeting in Paris. Fantastic. I think we were June by then. And then at the end of the year, we met in Brussels and once actually in Aberdeen in Scotland. So a great group of people. Really lucky. In a way, doing these studies in Europe is a bit like doing something here in the US that would draw on science input from across the states. Whether, I shouldn't probably say this, but whether at the time of Brexit they would have had a British chairman, I don't know, but they were certainly happy to have a chairman from the University of California. So that may have counted in my favor. Okay, so I said that we wanted to do something a bit more original than just collate literature for this report. So we did the classic thing, actually something that I would recommend. We went for case studies, and we went for 5 case studies across Europe. And I'll talk to you a bit about those in the next 20 minutes or so. The case studies were Southern Ireland, Brussels itself, Northern Italy, and Southern Sweden here, and Georgia, which is not part of the European Union actually yet. It's on the list to join. An interesting country, wedged between Russia and Turkey on the Black Sea. Quite a diverse range of study sites, and actually particularly for the area where we did a bit of original work, that is land use impacts of forestry, we really drew data from these case studies. The background here I've drawn is a map of intensity of forest management in Europe, with the red being more intensively managed and the green being the least intensively managed forest. So that was the other theme in our study. So I'm going to just run through, these are probably the nicest slides in the whole talk, and I probably should do more effort to get some decent images of some of these case study areas. The first one is our Northern Italy, and I'm taking these from the most intensively managed forest stand through to the least intensively managed. So we deliberately picked a gradient that did that. This is black poplar, Populus nigra, growing in Italy, very productive, 10-year rotation, huge, very productive, and almost farming actually in its intensity. Next one is interesting for a different reason. because in Southern Ireland, quite a lot of the UK, even in some parts of Holland, this species, one of our species, Sitka spruce from the Pacific Northwest, is an introduced plantation species, which is highly effective, actually, very fast growing, 34-year rotation, often grown in monoculture, but also can be quite a beautiful forest. And these forests, certainly in Ireland, are also used for recreation. So that's our second most intensive system, the Sitka spruce plantations of Europe. Moving to the Swedish site, a longer rotation, 80-year rotation, quite beautiful actually, these quite heavily managed forests in southern Sweden of a native species, at least now, Picea abies, Norway spruce. Nice places actually. And this is in fact the outlier of our studies in many ways. This is oak wood, Zonen wood on the outskirts of Brussels. If you know Brussels, you probably know this woodland. An old hunting forest, mostly oak, some beech as well, fagus. And I say it's an outlier because it really is a forest area managed mainly for its recreational needs. And it actually sticks out as an outlier in some of the data that we looked at. And this is, at least of our starting 5, this was the least managed system. This is Scots pine, Pinus sylvestris, growing on the slopes of Georgia, and very low intensive forest management over 150-year rotation. Okay, so like many of these studies, we started with a huge amount of data in Excel. I won't go through it, but for our case studies, that was our first approach, was to get data from a collaborator who knew the particular silvicultural system that we were interested in. So an intensive data harvesting activity. I'll tell you a bit about what those data were and how we used them. One of the things I've said we were particularly interested in was the intensity of management. This is because of this policy issue of, are we using plantations sufficiently effectively? The old debate, the public debate between natural versus plantation. So the way we've summarized the silvicultural systems in this report is through these diagrams where the area of the diagram represents the length of the rotation, and each blip on the rotation from sowing to final harvest is an intervention, whether that's thinning, fertilizer application, land preparation beginning, or final harvest. So this is the poplar in the Po Valley in Italy. This is the Sitka spruce in Ireland going to the 34-year rotation. 3 thinnings there, for example, in rotation. Vegetation management quite limited, 1 only. And then moving on, this is the Norway spruce in southern Sweden, longer rotation again, 80 years, not hugely intensive. Georgia moved up to 150 years. So quite a big contrast actually in the length of the rotation from 10 years through to 150 years. And this is the extra one that I said was the outlier, the recreational, largely recreational forest outside Brussels, 200-year rotation. And over 200 years, although there are a few thinnings there, it is actually quite a low intensity management system when you're 200 years as compared to 10-year rotation. So the first area I wanted to talk to you about was this business of land use impacts. And this is, there are a number of ways of looking at the land use impacts, that essentially the damage that a particular management system does to the land on which you're conducting the management. We, for various reasons, chose this particular thermodynamic approach. It's an interesting approach. It goes right back to a publication by Schrödinger in 1944. So it has quite a long history, thinking about the ability of the vegetation on a site to store energy in the form of the biomass on the site and to dissipate or use that energy. So take a proportion of the energy flow through the site to store for storage and harvest. So what we do at each site for the land use impacts evaluation is look at 17 indicators and we interpret them in the terms of the extent to which they're impacting energy storage and dissipation. 17 indicators within 4 themes, and those are the vegetation structure, biomass diversity or species diversity of plants and animals, of course, nutrient flows and water flows. And what you have to think about in doing this scoring is the natural reference vegetation on that site. So what would be the vegetation if the site was unmanaged? And that is considered to have a land use impact of 0. And at the other end of the spectrum, if you had a totally denuded site where all the vegetation had been destroyed, you would have no energy storage in the ecosystem, and you would have no energy harvest through the ecosystem, and you would have a score of 100. So it's actually quite a well documented. I've put a few of the references here, and references are of course in the report. It's quite a well documented approach, and actually it was particularly developed for looking at life cycle analysis, for integrating into life cycle analysis. That's one of the reasons it's gained in popularity, this particular approach. So this is the first sort of set of data that we did. This is rather small probably on your screens, and I'm sorry about that. So I will just take you through it. Some of the subsequent presentations of these data will be easier for you to see. So it's just our 5 sites ranging from the hybrid poplar through to the Scots pine. And I've got 1 cropland system on here. I'll say more about comparing forestry with agriculture, because we did our 5 forestry sites through this system, and then we also did a comparable agricultural system in each of those case study areas. So you can see how the study starts to get a bit more complicated. So this is just the percentage scoring for each of the 17 criteria that we were able to apply in forestry systems, things like leaf area index, free net primary production, above ground biomass, those are the vegetation indicators, and then various biodiversity indicators, soil and water indicators. And we took the average for each of those themes, each of the 4 themes, these are here. And then actually the average of these 4 give us the overall land use impact. And those are the data that I present here. So I'm hoping these are a bit easier for you to see than the numbers in the last data sheet. And there are 2 really interesting things about these data. So we have land use impact here on the y-axis, and I've arranged the ecosystems, the forestry ecosystems, by intensity of forest management. So we've got, we're going from the least intensive, that's the native oak, that's the Belgian site, through to the Sitka spruce, the pine in Georgia, that was the second least intensively managed, the Norway spruce in Sweden, the Sitka spruce in Ireland, and the poplar in northern Italy, that's the short rotation. So the green columns here show the overall land use impact of the system evaluated by the method I've just described. And as I said, 100% would be a totally denuded system, unable to store and convert energy, and a 0 would be the natural vegetation on that particular site if it was unmanaged. So the first thing to notice, the first interpretation here, is the green columns, which are the forestry systems, showing a really nice, clear increase in land use impact as you intensify the management. So the poplar system has the highest land use impact, and the least managed system, the native oak outside Belgium, that's the 200-year rotation, has the lowest land use impact. And actually that system is probably pretty similar, native woodland, to what it would be if there was no management at all in terms of its land use impact. So that's nice. One interesting thing happened very quickly. Our Irish Southern Ireland sponsors didn't like the way their Sitka spruce system was landing up in this scale. And so they asked us to do a native mixed stand, forest stand, in Ireland as well. So that's why this one is shown in blue. And this was added later on. And it's quite nice, actually, that it fitted well in with our other data set. The yellow columns are the equivalent agricultural system, and they lead to the second main conclusion. We've done these, actually, the agricultural systems, subsequent to the 2019 publication of the review, because the obvious question is, okay, so you've established this gradient in land use impact associated with management for forestry systems. What would happen if you use the same land for what would be the agricultural system if you didn't put forestry on that land? And outside Belgium, it would be wheat, and that's the land use impact of the wheat. In Southern Ireland, it would be a dairy beef mixture, and that's the land use impact. So interestingly, in all cases, except for the southern Sweden case, but in all cases except for that one, the agricultural system has a larger overall land use impact than the forestry system. So, I mean, that's something that intuitively people would have wanted us to believe up until now, that forestry has a lower land use impact than agricultural systems. And by and large, these are some data to support that conclusion quite firmly, actually. The exception there in Norway spruce, in southern Sweden, of course, the meadow system that would be an alternative is very close indeed. This is a almost naturally grazed or low intensity 1 year grass cut in the meadow areas. So in that system, you can understand why the alternative agricultural system, which is a rather low production system, may well have a lower land use impact than the managed Norway spruce stand on the same area. So there is one other thing I want to say. This is the last thing I'm going to say about land use impact, and it's interesting. I hope these numbers are large enough for you to see. The numbers along the top are the overall land use impact, the same numbers that I've shown you in the green columns in the last slide. So as you go from oak at an overall land use impact of 9% effectively out of 100, 9 out of 100, through to the highly managed short rotation poplar stand at the other end of our chosen gradient, you see an increase up to 37% effectively land use impact. So that's the increase that I've already shown you in the last curve. As you get a more intensive plantation system, managed system, you do see a larger overall land use impact. But if you consider the land occupancy, so that is the number of hectares that you need and the number of years that you need, so 1 hectare over 10 years would give you a land occupancy of 10, or 10 hectares over 1 year would give you the same land occupancy. But you also look at land occupancy per cubic meter of timber produced, then you are able to convert the land use impact to a figure which is land use impact per functional unit. So that is per meter of wood for each hectare and year that you have a site. So if you do that conversion, you actually lose that relationship, because per unit of timber produced, the land use impact of the intensive poplar system is very similar to the land use impact of the low management oak stand. So that relationship breaks down, and that is a very important conclusion, and something that is very interesting, and we are pursuing that in our current work in this area. What we can't do, what we haven't done yet, is look at land use impact per functional unit of the agricultural equivalent systems. We can do it. But the problem is, of course, that they're not producing wood. So it's not such a straightforward conversion. We need to look at the economics, and you need to value a ton of wheat against a ton of timber. Not an impossible thing to do, but a little more complicated than just simply looking at wood production. So land use impact per functional unit is something that we're working on for the agricultural systems. Okay, so that was the end of the first of the 4 areas in the report. And I'm going to deal, you'll be glad to know, looking at the time, I'm going to deal with the next 3 much more quickly. I'm just going to show you 1 slide of each, really to give you a feel for the breadth of science that needed to be reviewed to have the sort of policy impact that we wanted to have on the Brussels Parliament. So biotic and abiotic risk, one of the most important conclusions, of course, and it's really well substantiated by the science, is that risk is increasing. We were interested in how to present that risk, and our entomologist and pathologist like this scheme where you present risk as a combination of the level of hazard, that's the natural hazard, say the frequency of storms as it would affect wind throw in Europe, or maybe the frequency of fires might be the equivalent California equivalent, not something probably we can do much about, at least in terms of plantations versus natural forests. And certainly that's the case for wind, but the level of hazard, the exposure, so how economically, particularly economically exposed you are, how much value you place on each acre or hectare of land, and then the susceptibility. So risk is a combination of hazard, exposure, and susceptibility in this scheme. And what we were interested in looking at was the science that supports how you take the plantation systems, often which have the highest hazard, actually particularly because they may be monoculture, single species, single height, high value. How do you change that so that they are less at risk? How do you mitigate the risk through management? And we looked at quite a lot of work on that. You can't probably influence the hazard very much. You can very definitely influence your susceptibility to pests and pathogens would be the obvious one, by the way that you choose your species, by the amount of diversity you give the stand. And you may be able to also vary your economic exposure by the way you plan on a land scale level. So diversification in what you're in, for example, the age structure, the species structure, how you plan your landscape mosaic. So much of our case was that with plantations, with intensity of management, you can shift from this situation to this situation where your plantations are a lower risk than natural forests or semi-natural forests. Quite controversial, actually, that conclusion. This is the third area. Again, a way of summarizing a huge literature, actually, which is on the relationship between intensity of forest management and the net social benefits are attributed to a particular ecosystem service. So if your ecosystem service is woody biomass, you know that by intensifying your management, you can increase your woody biomass. But if you're interested in biodiversity, you might actually find that as you intensify your management, your biodiversity value will drop off. So the question we're asking in this model, this theoretical model, although actually for many systems, forestry systems, you can put points on quite a lot of these curves now. But the question is, how do you reach this sort of position where you achieve your optimum safe wood production, or maybe for climate mitigation, without an unjustified loss of, say, biodiversity or flood defense or soil erosion defense or recreational use, all these values that we attribute to the forest. How do you achieve the optimum balance of those systems, those outputs? So if you can put some points on some of these curves for your particular forestry system, then you can design your intensity of management with that in mind, and certainly avoid negative impacts. You might be able to tolerate a net social value on, say, biodiversity, which is still positive in order to justify a different net ecosystem service. Okay, so last one, and this is the question of stakeholder views. So in this this controversy over plantations and intensity of management, this is one that South America has seen, in particular, actually the monoculture eucalypts in quite a lot of the countries of South America. Some of the Mediterranean countries of Europe, Portugal, Spain, have seen the same sort of thing. And in northern Europe, it would be things like Sitka spruce or poplar plantations. This stakeholder problems, this unpopularity of managed or plantation forests. So one way of looking at that is to do the sort of thing that we presented in this study here. This is a Q analysis. If you're interested in social science, you're probably familiar with Q analysis. So this is based on semi-quantitative, it's based on surveys, and it's a way of understanding the views of different stakeholders and presenting them. So there are here 1, 2, 3, 4, 5 groups of respondents to questionnaires. And the only way I can ever understand this figure is to say that we are presenting the views of each of these 5 stakeholder groups against the various ecosystem service that they rate most highly. So it's a way of visualizing the differences in their views. And the extreme conservationists, for example, this is the green presentation here, rating conservation of biodiversity and protection of the ecosystem as their highest value. And in contrast to that, the extreme productivists, so this would be, well, it's wrong to characterize them too distinctly, but often that would be those involved in the forest industries or the forest processing industries, very keen on productive forests. They value maintaining timber production up here, and their value of conservation biodiversity actually zero. So that is why they're extreme productivists. Moderate productivists here in light blue, perhaps a more defendable position. So that would relate back to that balancing trick that I showed you in the last model. So I'm sorry, rather a lot to take in there, but I'll try in the last few slides to run through the conclusions that we presented in Brussels. So I haven't talked much about forest reproductive materials, but this is about choosing what you plant effectively and you need to consider both the production capacity and the ability to mitigate climate change. So going forward, that ability to mitigate climate change is one that certainly in our study came forward. I must admit, I haven't come across much of that science yet here in California, how to select your planting with a view to future climate. So that's an interesting one. This is the one on land use impact that I explained in a bit more detail today. So forestry plantations do have a lower land use impact than agricultural systems. And very importantly, the land use impact per unit of land and per unit of production may be lower, the land use impact may be lower for plantation systems, and that very much supports this mosaic approach to planning of forestry. So having some highly productive areas and some lower production areas, effectively land sharing and land sparing, as it's called in some systems, both have a place to play in getting your production out of the system for a lower land use impact. But there is an optimum in terms of forest management, and we saw that tail off in the ecosystem services, excuse me. That, excuse me, it would be my phone. So there is an optimum in the land use intensity that you can use without seeing a tail off of the ecosystem services from the system. This is the abiotic. So risks are increasing, that was our bottom line message. And you can reduce the risk by reducing the exposure of the system. Things like intensity of thinning, harvesting regimes, species selection, very important in that, developing resistant genotypes to particular pests and pathogens. Forests already are valuable in their regulating and socioeconomic services. You need to consider the non-market benefits in your forest planning, and you need to cost those in, and you need to take into account the heterogeneity of perceptions amongst stakeholders. So these were the messages that we were trying to get across from that really very detailed science review. The reason for the timing was the Green Deal in Europe, which is about using effectively the opportunity of the bioeconomy and production of biomass from plantation forests, using those things to uncouple degradation of ecosystems from growth of the economy. So how can the EU grow its economy without continuing to see environmental degradation? That's the concept at the heart of the Green Deal. And the Green Deal actually was passed by the European Parliament a few weeks after our presentation, and forestry is an important component to delivering that Green Deal. So there are substantial financial measures to increase the use of plantation forestry to achieve the objectives of the European Green Deal. And that's why some of the management recommendations that we were trying to highlight in our report became hugely important. I want to just close by saying a quick word about the US situation. Here, it's not called, you probably know this better than I do, it's not called the Green Deal. There was originally a New Deal after the Great Depression. So here in the States, it's the Green New Deal. And I think it's correct that there is that same interest in using forestry systems to supply biomass and some agricultural systems to supply biomass in order to break that link between environmental degradation and growing the economy. So when we think about forests here in California, I guess I'm not alone in thinking, first of all, about the Sierras in particular and those wonderful upland productive systems. But so I deliberately pulled up this slide. This is a site that the Taylor Lab are working on here at the university farm out on the west side of Davis. This is poplar, not black poplar, but trichocarpa, a nice native species of poplar, but highly productive, highly intensive system. This is a few weeks after planting, and this is the end of 2020 last year. Really productive and high intensity plantation systems. So I think my own view is that even here in California, there is some interest in producing biomass through these sorts of systems. Okay, thank you very much. I've gone on a bit longer than I probably should have done. Please forgive me for that. And I will try and check out the chat area. Or will Ali do that?
I will help you there, don't worry.
Okay, thank you, Ali.
Thank you very much for your talk, Peter. Our first question is from Hugh Safford, wondering what hazards made their way into your risk assessments?
Yeah, good question. I mean, it's interesting that fire is so low down the agenda, at least in Northern and Central Europe. Some interest, as Hugh probably knows, in Southern Europe. So the political balance normally in Europe is that the northern countries, Sweden, Britain, Norway, Denmark, those countries are worried about wind. Britain is, I think, the windiest country in Europe, and probably Sweden is, Norway is the second. So wind hazards very high on the agenda in Northern Europe, and fires becoming higher in Southern Europe. Universally, there is a concern over pests and pathogens. So something like some of the bark beetles, conventionally a big concern, and new diseases coming in, actually. So, yeah.
Great, and Hugh also says he would love for you to send him the Nizhnik et al. 2015 citation.
The one on which the ecosystem services balances was based.
Yes, I think that's right.
Yeah, I can certainly do that, Hugh. Very happy to do that.
All right, our next question is from Christina Galitsky. She asks, you mentioned the results for mitigation, risk, etc. on the triangle slide, that they were quite controversial. Have you presented that to other organizations, and can you share any specific reactions? Has there been any changes that you have seen in policy or forest management based on the results, or do you expect any changes?
So it's controversial. Well, for a number of reasons, really. It's because to mitigate risk is a costly exercise for the forest manager. So, and the alternative is to insure against risk. So there has been an attempt to get the insurance industry interested in mitigating, in helping to cover the risk, financial risks. I don't think that's been very successful. So you're back to persuading. The old argument is always persuading investors in forestry to spend the extra money on plant supply that is risk tolerant and on a slightly less productive system that is less wind susceptible. So that means you can't just grow, say, your maritime pine on the west coast of France in monoculture, which it would be naturally the most productive system on the sort of, say, the Bordeaux coast of France. So that's a very good question. And how to mitigate risk in forestry, how to persuade investors to pay the extra for the lower risk strategies, I think will not go away as the risks continue to increase, actually.
Okay, thank you. All right, I have a question about how these results are used by policymakers when considering policies for land use change. Are there efforts to balance the provision of different types of ecosystem services in different areas? For instance, by reserving some areas for managed forests and other areas for conservation of natural systems.
So it tends, the area of protected forests in Europe is quite low. So reserving areas of land for particular land use is not, it doesn't tend to be the way they've gone. So, the investment here in national parks is phenomenal by comparison to that approach in Europe. So the approach is more of an economic one. So how do they do it? So that's actually why this policy report was so important at the time. I talked about the need to get the politicians on side. And if you're able to do that, then the measures for implementation effectively become regulation and financial incentive. So you can certainly regulate for plant protection. You can regulate to reduce the movement of uncertified plant material. And then you can, and the EU will, under the Green Deal, they will incentivize the establishment of production plantations to quite a substantial extent. So there's the subsidy per hectare per year for producing timber from managed forests is firmly in place now in the Green Deal, and I think it will stay so. Yeah.
Very, very interesting. Okay, the last question here is from Becky Wayman. What proportion of plantation forested lands are privately owned in the study region versus publicly owned? What sorts of incentives or policies are needed to push plantation forest management in the direction the report suggests, given the land ownership?
So land ownership is hugely important as an issue. And I mentioned that when I showed those few slides of controversy. So it's particularly actually, well, traditionally in Europe, the issue would have been private ownership versus public. And the trend has been towards more private ownership in recent years. So that's because of the whole move away from government ownership of industry. So government stroke national ownership has been declining in many European countries and public ownership increasing. And yet you have that controversy that private ownership is unpopular. So the move in those countries that are responding to that public pressure, and some are and some are not, but the move in Europe would be towards community ownership, creating opportunities for community ownership of local forest areas. So the only other comment I would say on that is that in South America, and probably, I think it was Rebecca who asked that question, may have experience of this. The other part of private ownership is this issue around multinational ownership. So some of the large forestry companies owning and managing substantial tracts of land in developing and developed countries or countries in transition is a real issue. And those countries really need to take on board some of the science of the type that I've presented today, the public perception and the balancing of ecosystem services. And some of those multinationals, I've done a small amount of work with a consortium of large multinational forestry owners. Some of those companies are clocking that particular need for change, and there is a real need for change there.
Well, once again, thank you, Peter, and thank you to those who attended the presentation today. Our next Feral lecture will take place on Wednesday, March 10th at 3:30 p.m. and it'll be a combined webinar from both Mark Meyer and John Williams. You can check out the California Fire Science Consortium website for more information and details as they become available. So thank you, Peter, and thank you all, and take care.